Yeah.
Good afternoon, everyone. I'm Chenchen, the leader of Group 2. Today, we are going to produce a final report presentation of our project, producing a military spy robot. Before we start, let me introduce my team members and the outline of presentation. They are Kinson and Felix. I will talk about the methodology of this project and the production process of our spiral work, including the work division, the ESP32 camera range server setup, the Arduino IDE setting, and the list of required resources. Then I will present to you our discussion of the project details, theme, and the prototype specifications, the prototype test results, a summary of the motor, feedback from the shareholders, and the future development plan. Next, Felix will show you the challenge we encountered during the production process and the solutions we came up with. Finally, Kinson will conclude our presentation by presenting our group and individual testimonials, the reference list, and the appendix. For the methodology of this project, first our team sat together to discuss design and draw a sketch for the military spy robot to decide what the spy robot can perform. After that, we prepared the required materials according to our first sketch. With the aid of trade model lecturer, Mr. Zhu, but then we produced a prototype of the spy robot by setting up a few programs to control each model. We also test the prototype for its Wi-Fi connections stability and motion sensibility. Finally, we collected some stakeholders' feedback for future input. Before we explain the production idea, let's have a look at the electrical circuit diagrams of the PCB of our spy robot. On the left is figure 1 showing the semantic produced by the EDA software Eagle, and on the right is figure 2 showing the board and in the interconnections of different electronic components. Both diagrams present all the components in place, including connectors, LED indicator, and the power supply, which are connected via electronic wires shown in red in the diagram on the right. For the production process of our spiral work, there were 3 stages. There were robot design, wireless control, and robot fabrication. As the first stage of robot design, our spy robot was designed using Fusion V60, and the circuit board was created using Eagle. Second, we programmed the module using Arduino IDE or to connect with the robot for the wireless control. Lastly, about the robot fabrication, we used the 3D print to make a flat circular shell of for the robot, and we expanded the robot's chassis using plastic materials along with 2 motors and a camera. Regarding the ESP32 camera web server setup, first Arduino IDE was used to set up the program. Arduino IDE is a software tool used to write, upload, and monitor the code that run on the Arduino block. Next, we transferred the programming code to the ESP32 camera. At this point, we obtained a URL which we then entered into a web browser. Finally, test the ESP32 camera could be not controlled via the serial monitor. Now let me pass to Felix.
Thanks, Jamie. Regarding the Arduino IDE setup, we use these programming codes to use the Arduino IDE as a compiler to give commands to the ESP32 module to control the spiral board. Here are the codes controlling the spiral board to move forward, backward, left, and right. These lines were used to transmit the videos from the spiral board's camera to the computer monitor. Here are the resources we need. We used a number of tools and parts for this project, including but not limited to an ESP32 Wi-Fi module, 2 J1280 PN motors, and a DRV8833 motor driver module. This is the table of specification of our spiral board. It is 183 mm long, 182 mm wide, and 50 mm tall. It weighs 100 grams and is gray. The shape is flat cylindrical. It has a microphone and a camera. The case is made of plastic. It can take photos, record audios, record videos, and move with a pair of wheels. To ensure that our spiral board can fulfill the requirement stuff in our project plan, we conducted 3 types of tests. There were camera testing, mobility and control testing, and durability testing. For camera testing, we positioned the robot in different locations in the school and control it to capture image and record videos. About mobility and control testing, we test the robot's ability to navigate through the obstacle in the route we designed. As for durability testing, we conducted free falling on the spiral board. There were 5 trials for each testing. All the testing results were satisfactory. The camera resolution was 600 times 800 with a 120-degree viewing angle. Moreover, the remote control range was about 30 meters and the latency was not noticeable. When we controlled the spiral board beside, the spiral board could survive free falling up to 2 meters above the ground without damage. As for the feedback from the shareholders, we conducted a survey using the questionnaire shown here. A total of 3 teachers and 8 classmates completed the questionnaire from the 4th to the 14th of June 2024. For question 1 is about the working ability of the spiral board under extreme conditions. The French score was 3.27. Less than 1/10 show negative responses to this question while the rest of the respondents held the opposite way. It might be due to the fact that the spiral board held a third whole case and the signal was not easily interfered. Even in a very hot and humid environment. For question 2 is about the spiral board can communicate and respond quickly. The average score was 2.91, less than 1/5 shown negative responses to this question, while the rest of the respondents held the opposite way. It might be due to the robot's ability to communicate in real time, allows it to transmit information back to its operators and it gathers it, and the robot's ability to communicate and respond quickly factors influences that effective intelligence gathering. For question 3 is about the spiral board as a user-friendly interface. The average score was 2.91, less than 1/5 showed negative responses to this question, while the rest of the respondents held the opposite way. It might be due to a user-friendly interface, allows the robot's operators to easily control the navigation, the robot's functions, and the user-friendly interface can make the robots more adaptable to different user preferences and operational scenarios. Due to the limited size of the 3D printer, it is not feasible to print a suitable case for a spiral board at this time. The camera is currently oriented upward. Our plan is to use a larger 3D printer to plan a more suitable case, allowing the camera to be oriented forward. Now let me pass to Kinsey.
Thank you.
postman to listen to the dispatch recruit to the decimal for so that they future video and how to add buffer control to add project ECPPC and for create 1, 2, 3, to give font for the available. Today, thank you for the